Hello everyone, welcome back to another AP Physics 1 Daily Kinematics problem. Today we'll be going over question 21 in the MIT AP Physics 1 practice problem book that will be in the description down below for you guys to access. With that being said, let's go ahead and read the question. It says, starting from rest t equals 0, a car moves in a straight line with an acceleration given by the accompanying graph. What is the speed of the car at time t equals 3 seconds? And we have our answer sheets down here. So one thing we need to know to understand this problem is that this is an acceleration versus time graph. And the corresponding from acceleration and velocity is that velocity is equal to the the change in velocity over the change in time is equal to acceleration, or delta v over delta t is equal to acceleration. And to get from acceleration to velocity is the same thing we do to get from velocity to displacement. If we have a velocity versus time graph here, so this is our velocity versus time graph, to find the displacement, you would go ahead and find the area under the curve like this. And what is displacement? Displacement is equal to x final minus x initial. And doing that, the same thing, to find the area under the curve of an acceleration versus time graph, you're going to find the acceleration, you're going to calculate the area under the curve, and that's going to be your delta v, or your change of velocity. But this can also tell you, if it's a straight line, what your velocity is. And in this case, we do have a straight line right here, so we can go ahead and find out what the velocity is. So finding out when it says that time t equals 3 seconds, we're just going to go ahead and find the area from 0 seconds to 3 seconds. And to do that, we're just going to go ahead and draw a line down here and find the area of this part right here. And to find that, we're going to have to split this into two different shapes. We're going to have to split it into a triangle up here, because I can see that this makes a 90-degree angle, so that's going to be easy. And then we're going to make our little rectangle here. So calculating the area, it goes over 1, 2, 3. So this is a 3 by 1, 2, 2. And we know the area of a rectangle is length times width. So 3 times 2, and that equals 6. So this is going to be 6. And we have a 1, 2, 3. So this is going to be a 3. And this is going to be a 1, 2, 3. So this is going to be, 1, 2, 3. Just want to make sure 3. So this is going to be a 3 by 3. So we're going to do the area of a triangle is base times height divided by 2. So we're going to go ahead and do 3 times 3 divided by 2. And 3 times 3 is 9. 9 divided by 2 is going to be equal to 4.5. And we're just going to add up these areas together to calculate the total area. So that's going to be 4.5 plus 6, and that gives us 10.5. And 10.5 matches up with our choice D, letting us know that at time t equals 3, it's going to be equal to 10.5 meters per second. And the reason this works in this case is right here it says starting from rest. And starting at rest, as I said earlier, delta x, which was the displacement, we said that displacement, so delta x was equal to x final minus x initial. If this is our delta x will say, our delta v in this case, here, let me draw this. This is going to be our delta v is equal to v final minus v initial. Our delta v we said was 10.5. So let's say our v final, because this is the velocity at 3 seconds, minus our v initial, and it says starting from rest. This is going to be 0, giving us that 10.5 is equal to our v final, which is why in this case we can go ahead and use the displacement not the displacement, the area under the curve to calculate our velocity. I hope you guys enjoyed the video. If there's anything you didn't understand or was unclear, please comment down below. And forgive me for not having good voice this video. I am a little sick at the current moment, but that will not hinder me from making these videos, because you guys need these videos, and I hope to make you guys prepare well for this exam. I hope you guys have a good day. Remember to continue your prep, and remember to enjoy life.